Alright, so welcome to question number 2, still on simple problem involving motion part of an object. So welcome to question number 2. And question number 2 says, a car travels 10 kilometers due north and make a U-turn back and travel further distance of 6 kilometers in 0.2 hours. Calculate A, the average speed, and then B, the average velocity. So we'll be calculating these two quantities, velocity and speed. Now, solution for average speed. So we can now say that for average speed, now given, we can see that, let's say distance due north, I can call it dn equals 10 kilometers. Yes, and then distance due south. The question did not mention south, but I know when they said to make a U-turn and started coming down, so a U-turn means that you're coming down, and coming down is going nowhere other than the South Pole. So we can say, that's why I believe that it is South Pole. We can say that due south, that's ds, equals 6 kilometers. Yes, and then the total time given, that is, I can say t equals, of course it was given as 0.2 hours. Yes, now let's go further, recalling the formula of speed. So let's say average speed, I can say my average speed is SAVG equals total distance, yes, all over the total time taken. Yeah, I can come down and say that this is equal to, my total distance is equal to, of course I was given 10 kilometers plus 6 kilometers, make them kilometers here, equal, over 0.2 hours. Yes, so therefore, equals 16, 10 plus 6, 16 rather, all over 0.2, 16 kilometers an hour. So I can say that therefore my S average equals 10 plus 6, 16, 16 divided by 0.2, I will have, if you use your calculator, I'll have that 16 divided 0.2, of course 0, if I do 2 divided by 16, it will give me 8, and 8 now, because of this 0 in standard form, 1, 2 to 10, so if I do 8 times 10, it gives me 80, that is 80 kilometers per hour. That's my average speed. So we'll move further by calculating for my average velocity. So for average velocity, now listen to this. For average velocity, velocity means displacement over time, and displacement has to do with, if I start a journey from here, from this point, and move towards another point, so displacement has to do with change of distance or change of direction. That's what displacement is. So by this act, using the Cartesian graph, let me explain. The car was moving northward, upward, and they said it makes a U-turn, and this U-turn means that it's coming downward towards the South Pole. And of course, in Cartesian graph, we know that this axis is plus, this axis is negative, and then this axis is positive. Also, this axis is negative. So since it's going upward is positive and it's coming downward, it's now become negative. So using this idea, we believe that also distance due north, let me continue, that dn will be equal to 10 kilometer, of course it was given, and then comma ds will be equal to minus 6 kilometer from what I explained, because it's coming down, so it's now negative minus 6. And then of course my total time equals still remains 0.2 hours. Yes, so let's go further. Substitutionally, I have that my average velocity, that's v, you can use this as average velocity, equals displacement. Of course, velocity definition is displacement all over total time, or time taken rather. So I can say that this, in using my formula that I have, that dn minus ds all over tt. So substitutionally, I have that my average velocity equals, my dn is equal to 10 minus 6, right? My dn is equal to 10 minus 6. So from this, I have that all over my total time 0.2 hour. Of course, this is in kilometer and this is in hour. Yes. So from here, move further by saying that 10 minus 6 gives 4 all over 0.2, and 4 all over 0.2, the same thing. If I do 2 going to 4, this 2 going to 4 2 times, of course in standard form like this, 2 going to 4 2 times, and then 2 times, so I will have my 0 here. So instead of, if I do 1, so automatically become 10. So 2 times 10, 2 times 10 now gives 20. So 0.2 into 4 is 20. So I have it as 20 kilometer per hour. That is if I'm not going to use calculator. That's why I'm explaining this pattern. So this is what we have. This is what we have. Of course, we can leave this one to be just normal 6, please. Leave it at normal 6. Leave it at normal 6. Of course, displacement will be given, the formula will be given. So if you leave it at minus 6 and then you're substituting the value of the s as minus 6 here, automatically change to plus. That's why I have to change it to positive. So leave this part as positive value. Meanwhile, we'll work with this main formula. So see you next time. We'll be solving problems on motion, a lot of them. So stay tuned. I still remain Mavis Kiko, Makitech Services. Do well to refer us. Thank you.